Hello. AI ML has really taken over our working lives. Whereas previously, very few people, perhaps only 10 people at the FT, had knowledge of AI ML. But now is the time where everybody needs to acquire some knowledge of this area. An important part of ML AI is MLOps. It's crucial, and in this video I will explain the responsibilities and skills to give you a introductory understanding of this area and explain how the engineers work in the ML AI space. For the last 8 years, I've worked in various teams across the FT, and I've noticed and appreciate that the most popular language used is Node.js. That makes sense because it's fast, there are lots of libraries, lots of support in the community, and people are knowledgeable in JavaScript. But our first big challenge is that in the ML AI world, Node.js really is inadequate. The preferred language is Python. There are lots of cool models, cool tools there based in Python. You'll be familiar with ChatGPT, which is built on Python, and Llama and PyTorch, TensorFlow are all Python. And you may have heard of TensorFlow JS based in Node.js, but that has very limited features and capabilities compared to Python's TensorFlow version. Python is much better. So your first challenge, if you are a Node.js user, is to gain knowledge of Python and improve your skills in that area. I was a strong Node.js developer myself, and I found Python relatively easy to learn. There are plenty of courses out there, and ML AI code isn't too long. It's relatively short, and lots of code can be reused. So my challenge to you is to learn Python. How we work in the normal dev environment, web development, API development is very different from ML AI. In the ML AI world, we use notebooks, which may sound like some strange analytical thing, but Notebook allows you to do lots of experimentation, to try out different things, and Notebook allows you to load multiple models, which can be 1-2 gig in size, and also you can download lots of data, which could be complex query data, which can be loaded. So if you want to load this information and keep it and experiment with it and try out different things, then the best way to do that is using Notebook, because everything is retained in memory and it allows you to write chunks of code and then see its output, which is kept, and then you can do the next piece of code and see the next piece of output, and so on. And it's really nice to see the output of each piece of code, which could be a picture, a graph, or a table. It's very interactive. Previously in web development, API, using VS Code, you do unit testing, you run tests, you write more code. Notebooks is a very different way of working. So your next challenge is how to learn how to use notebooks and come up with some really cool AI ML applications. GPUs are very important. A web API development, everything can run in under 1 second. A web page can display in under 1 second, which is very quick and all very well. But in the ML AI world, things can take a long time to run. You would have seen on ChatGPT that you don't see your results instantly on a page, but rather you see the message develop word by word, which is a little slow because it requires a very powerful machine. GPUs are important because in the NLP world, we need to do many things at the same time, all running in the same algorithm. So thousands of things running in parallel. And a CPU just isn't appropriate. A CPU can run different things in different algorithms, but a GPU can do magnitudes more at the same time. The challenge with GPUs is they are a little difficult to set up for use. You need the right drivers, the right toolkits, the right library, the right machine, etc., all set up. But when everything is in place, it's wonderfully fast. You can do everything very quickly. ChatGPT, large language model, need a minimum of 4 GPUs. And that's how crucial they are. Now, dev environment, web development, API development. It's easy to use repos. You can use any computer, download and run. But with ML AI, it's difficult to make it work on different machines. With the OS, environment, libraries, CPU, GPU, if these are different, then issues can arise. Which is why it's nice to try and make sure that people in the team have the same environment, the same hardware. And there are 2 ways to go about that. Using Docker. We like to use Docker integrated with VS Code and to work on a local machine. And yes, the hardware is different, but the OS, libraries, toolkit dependencies are the same. So it's easier to share work on projects. However, recently we introduced something very new, something very cool called Workbench. It's development in the cloud. So you open up a web browser and you can write your code, same as VS Code, but it runs in the cloud, which is incredibly powerful and has many benefits. It means everyone can run on exactly the same hardware and software. Everything is ideal, and you can expect the same results with no conflicts, no variation, but everything is standardized. Also, you can have much more powerful machines, so 100, 200 gigabytes of memory and 4 GPUs, so it's a lot more powerful, meaning we can run heavier training model development, and we can run lots of heavy tasks at the same time as they're all running on the cloud, and you can continue working normally on your computer. So there are many benefits to that. That's our dev environment, which is very advanced, very cool compared to what other companies have. So we're very proud of our Docker Workbench setup. You may have heard of SageMaker, which is kind of similar, but Workbench is significantly cheaper and more flexible and integrates better with our infrastructure. In the FT, for deployment and platform, Circle CI and Heroku are very popular, which I appreciate. But Heroku isn't suitable for ML AI because it cannot use GPU. Heroku is limited to 2 gigabytes of memory, which is insufficient. ML AI needs a lot more memory. Heroku doesn't easily integrate with our backend data, single store, BigQuery, Redshift, which is why we need to use a different platform with GPU, more memory, which is easier to integrate, and what we use is called Kubernetes, which is open standard and very popular. If you work in MLOps, the number one most popular platform is Kubernetes because it has lots of important skills. So how do we deploy using Kubernetes? Well, there are several ways. You can deploy through Circle CI. We use a couple of deployment methods, one called connect, which is a really nice UI where you can see what's been deployed and integrates really nicely with the dev environment, and you can type please deploy and it will deploy on Kubernetes. Second one is using Helm charts, which allows us to manage resource that we need in infrastructure. This is more complicated to deploy, such as LLM like Llama, and needs lots of GPU resource. And we will look at that more a little later on. This year, the MLOps team have a new OKR. We want to achieve gold standard, so our infrastructure can provide customers with gold standard support. We've created a very detailed plan to include all of the requirements that we need to aim to have finished by the end of H1 sometime this summer. And I will show you that document so you can have a look at what's included to achieve gold standard. But it includes failover support, rollback, ops, integration support 24/7, etc. The MLOps team consists of myself, Galen, Pavlin, and one more member of staff, hopefully to be recruited soon. The team has two different roles. MLOps, which I'm explaining to you in this video today, and the other role is ML engineering. The ML engineers focus on working with models. They develop new models, train new models, evaluate and choose which are the best models to use. They're very experienced in ML, AL algorithms, different methods. They're also very skilled in data engineering, feature engineering. MLOps focuses more on infrastructure, so package, containerize, test, deploy, orchestrate, Kubernetes, integrate, scale, and monitoring. So there are many areas of our work which overlaps, where we collaborate, and it's worked very well since the team was set up. So although our roles are distinct, generally the engineers focus on models and data feature engineering, and MLOps are very knowledgeable on deployment, infrastructure and monitoring. It's very difficult to run an LLM locally because the best LLM model, for example Llama, needs a minimum 4 GPU. So we cannot run on a local computer. We need to deploy the infrastructure, and scaling can be hard because of the 4 GPU is very expensive, and AWS doesn't have sufficient GPU. They're continually adding more to meet global demand. Some interesting things about an LLM. Firstly, when you submit a prompt, if you want a full answer, you would have to wait 30 odd seconds, which is a long time to wait. But the trick they use is that they send information bit by bit. Slowly, you receive a stream of information, which is exactly as you see on ChatGPT website. It's interesting how different that is from how we normally work with API website development. And this is new technology, new way of working, new infrastructure, and new skills. Now, feature store and feature engineering. If we, for example, think about sign language, you want to create a model to recognize sign language. How would you do that? You need to think about what inputs to give the model. The inputs could be something very raw, such as a static image of a sign, but it would be difficult to build a model based on that. A better way would be to first identify hand shapes that are used. Closed hand shape, open hand shape, thumbs up, for example. Then facial expression, positive or negative facial expression. Also the direction that a hand moves and orientation of the hand. These different features can be added to the model: hand shape, facial expression, direction, and the model can then more easily identify the signs. That's feature engineering. However, a challenge is that we need lots and lots of data, which needs to be held in a feature store, which could be very large. The store can be online or offline. Online would be very fast and low latency, so real-time use, such as a website. So you could view the signs in real time. Offline would have longer latency, where you would download for model training or longer processes. And the reason we have these separate is because online is very expensive and requires a fast database. Offline can be much cheaper, such as Redshift, long latency to download, which is fine. So online single store such as DynamoDB. So that's feature store, and it's our responsibility to build and deliver features to help us build models and to help us run models in really cool use cases. Monitoring is very important. We have standard monitoring, as you would expect, using Grafana, Splunk, and Prometheus, which is all well and good, but AI ML requires additional specialist monitoring, to monitor model drift when a model becomes out of date. Also data drift when underlying data changes. We need to monitor, so when this happens we can update as required. And also metrics. Currently we use Graphite, Prometheus and Splunk, but we think that we would like to look into a new open standard called Open Telemetry, because we have had some issues with Prometheus. For example, it doesn't work well with our Connect platform. Because of the load balancing, it's difficult to extract monitoring data. Hopefully Open Telemetry will answer that problem for us. So that's a new thing we'll be looking at sometime this year. ML AI has lots of code that we reuse, and we like to share code, which is why we created a library. So code can be stored and reused, and it can be Python, R, or any other language. The library is held in the FT's new infrastructure called Cloudsmith, similar to NPM. We upload the library to the central location, which is secure and confidential, business secure. Cloudsmith is like our proxy for an external package, which is useful because if the external package has an issue, a hole, then Cloudsmith will be aware, FT will be notified that there is a security vulnerability and it needs to be replaced. So we deploy our models on our Kubernetes environment. But how can external users, FT users, access our models? We use API Gateway. It's like a proxy. So we have the model, the proxy, and the user. The reason we use a proxy is because it gives us lots of useful tracking, monitoring information, and we can also control rate limits to specific users, setting how many requests they can make per second, which is important because some models cannot handle too many requests at the same time. Also, API Gateway has nice metrics, which allows us to see error rates, latency, and also, importantly, informs us precisely who is using our models, because API keys are allocated to each user, which is really useful. And we have a Splunk dashboard, which we can adapt to meet our needs, which is extremely powerful and cool. So that's it. I think I have covered most of the key points of MLOps. I would be more than happy for you to ask me any questions you may have, share your thoughts or comments, either directly to me or in the Accelerate AI channel or FT Data Science channel. Thank you for watching.